Hello everyone. Today I'll be telling you everything about the HC SR04 ultrasonic distance measuring sensor. The reason I made this video is because in the previous video in which I showed you how to make a distance measuring system using Arduino, I didn't really explain how this sensor functions. So in this video I'm going to do that. First of all, what is this sensor? Well, by using this sensor we can calculate the distance between the sensor and an obstacle ranging from 2 cm to 4 meters. Now let's have a look at the components of this sensor. This sensor has two transducers. One is the transmitter which outputs the ultrasonic sound pulses, and one is the receiver which receives the ultrasonic sound pulses. There is also an oscillator present on this sensor. This oscillator helps in performing all the timing functions of the sensor. It has 4 output pins which we will connect to the Arduino when we will do the wiring. Now let's have a look at how exactly this sensor works. First, the transmitter transmits ultrasonic sound pulses which reach the obstacle and get reflected back. These sound waves are then received by the receiver. Thus, the sensor is able to calculate the time required for the sound waves to reach the obstacle and then come back. Thus, we can find the distance between the sensor and the obstacle by using a very simple formula, that is, distance is equal to speed into time. In this case, the time is calculated by the sensor and the speed of sound we all know. You can notice that we have multiplied the distance by 2 as the sensor calculates the distance that is required for the sound waves to reach the obstacle and then come back up again. So in this way we can easily calculate the distance between the sensor and the obstacle. Now let us actually do this by connecting the sensor to the Arduino. For this, we will need an Arduino Uno, an HC SR04 sensor, a breadboard, and couple of male-to-male jumper cables. Now, let's do the wiring. The wiring is very simple. First, take the Arduino Uno and the breadboard. Now, attach the sensor to the breadboard. After that, attach male-to-male jumper cables to the corresponding columns of the sensor. Now, connect the VCC pin of the sensor to the 5V pin on Arduino, GND pin to GND pin. Connect the trigger pin to digital pin 9 and echo pin to digital pin 10. Now attach the Arduino to the computer. Now let's have a look at the code. In the code, first we declare the pins to which the trigger pin and the echo pin are connected. After that, we create some variables which we will use later on while calculating the distance. Then, in the void setup, we declare the trigger pin as an output device, and then we declare the echo pin as an input device. The echo pin is an input device as it provides Arduino the time required for the ultrasonic sound pulses to come back from the obstacle to the sensor. After that, we set the baud rate of the serial monitor at 9600. In the void loop, first we turn on the trigger pin for 10 microseconds. Thus, the transmitter emits an ultrasonic sound pulse. After that, we turn off the trigger pin. After that, in the variable duration, we store the time required for the ultrasonic sound pulse to come back from the obstacle to the sensor. After that, by using the basic formula, distance is equal to speed into time, we calculate the distance between the sensor and the obstacle. And finally, we print the distance in the serial monitor. Now let's upload the code. Before ending this tutorial, I would like to give some information about the specifications of this sensor. So, the range of this sensor is from 2 cm to 4 meters. The power supply required by the sensor is 5 volts direct current. The working frequency, that is, the frequency of the ultrasonic sound emitted by the sensor is 40 kHz. The working current of the sensor is 15 milliamps and the measuring angle is 15 degrees. I hope you liked this video and thanks for watching. And if you have any questions or doubts, you can always ask in the comment section.